Hi, so welcome to the last video of the fifth lecture, and we are going to discuss how to compute confidence intervals of population mean using T statistics. So in general, we use T statistics instead of Z statistics when we analyze relatively small samples. And this is the formula. It should look familiar for you at this point. So here X bar stands for sample mean, S stands for sample standard deviation, and N stands for the number of observations. And in very general terms, T distribution is very similar to normal standardized distribution or Z distribution. However, its shape will depend on the number of degrees of freedom. And here the idea should be very intuitive for you. So number of degrees of freedom is calculated as the number of observations minus 1. And if you collect more observations, then there is a higher chance that your sample is representative. So that's why T distribution will look more similar to normal Z distribution. Actually, you can use Gretel in order to compute T distribution for the different number of degrees of freedom. I'm going to show you this in a second. Okay, so you should go to Gretel, choose Tools, and Distribution Graphs. We are interested in T distribution, so that's why here we should only provide the number of degrees of freedom. As for now, let us assume that we have 5 degrees of freedom because of 6 observations. And this is the graph. So you can notice that it's somehow peakier than normal distribution. So let us check what it's going to look like if we assume a bigger number of degrees of freedom. So this time let's assume 30, for instance. And here we are. It already looks more similar to the normal distribution. Let us choose some bigger number, let's say 1000. And yes, at this point it starts to look very similar to the standardized normal distribution. So I believe you've got an idea. So yeah, the number of degrees of freedom is crucial for us, and it will affect the way through which we compute confidence interval. So this is the formula. In order to compute confidence interval, you have to pick the sample mean. Then the upper boundary will be sample mean plus t-value times s over square root of n, and the lower boundary will be x bar minus t times s over the square root of n. So here t of alpha over 2 corresponds to t statistic we are going to take from the table. And alpha here stands for the chosen significance level. In other words, if you want to compute confidence interval, you have to check the respective t-value for the chosen value of alpha, and depending on the number of degrees of freedom. So here we have to split alpha by half because we are interested in both sides of the distribution, which is symmetrical, as you remember. So yeah, here we are going to have sample mean, and our confidence interval should be symmetrical as well. So you can check the table for t-values. As you can see, you have the number of degrees of freedom. Of course, this is only an extract because we are going to analyze a relatively small sample. And here you have the corresponding assigned value of alpha. It's really easy to notice that when you increase the number of degrees of freedom or the number of observations in a sample, the corresponding t-value becomes smaller. Here again, if you collect more observations, then you can design the confidence interval of the narrower boundaries. In other words, you can be more precise about the value of the mean. So let us consider an example. 25 students play a game, their average score is 103 and standard deviation is 12.1. We have to compute 90% confidence interval for the average score. So in this case, of course, the value of alpha is 0.1 and we have 24 degrees of freedom. So we are going to check the table, 24 degrees of freedom, alpha corresponding to 0.1 should be split by half, so that's why we are interested in t of 0.05 and t-value is 1.711. So then we can just use this information in order to compute confidence interval. Sample mean is 103. Standard deviation is 12.1. We've got 25 observations. When it comes to t-value, we already detected it's equal to 1.711. So this is our confidence interval. For the lower boundary, you subtract 4.14 from 103. For the upper boundary, you have to add 4.14 to 103. So actually that's it when it comes to t-distribution and computing confidence interval for t-distribution. So thank you for watching and see you in the next lecture.